Alright, in this video we're going to look at using the unit circle a little bit more. This is still 13.1 in your book. Call it part 2. Okay, so let's go back to the unit circle for a moment here. If we were to draw this, keep in mind that this is a circle with a radius of 1. Alright, and if we call this point xy on our circle and make a right triangle out of this, we know that's x, this is y. We also said earlier that that is the same as the cosine of our angle, so our angle is really inside here. And then sine of theta, that would be the coordinates for xy. Well, we know that from Pythagorean theorem that x squared plus y squared is equal to 1. So since that is true, it must be the case that cosine of theta squared plus the sine of theta squared would equal 1. Okay? And by the way, sometimes you see it written like this: cosine squared of theta plus sine squared of theta equals 1. Or you see it reversed: sine squared plus cosine squared equals 1. Alright, this is given to you in your formula packet. So this is a popular trig identity. We're going to see it in an example coming up. Alright, so just keep it in mind. It comes from the unit circle. Don't need to know that necessarily, but you just have to know how to use it. So here's an example. Alright, so in our example here, we're told that the sine of 50 is 0.766. Then it says, hence, we want to find, and there's going to be, 5 or 6 questions here. But the first one is the cosine of 50. So what we can't do is just punch it into the calculator. Hence means we have to use the previous result somehow. Well, to find our cosine of 50, notice how the angle matches what's given. Okay, since the angle matches, we can use the identity that we just talked about in the previous page. Cosine of theta squared plus the sine of theta squared equals 1. Now, by theta, we mean the angles must be the same. So, the cosine of 50 squared plus the sine of 50 squared equals 1. Alright, so if we clean this up a little bit, the cosine of 50 squared would equal 1 minus, now the sine of 50 is this 0.766, okay, squared. Alright, so I just subtracted over that term because I'm trying to get cosine of 50 alone. And then my final step here, the cosine of 50 would equal, now I'm going to have to square root each side to get rid of that square. So I'm going to end up with a plus or minus the square root of 1 minus 0.766 squared, which is going to give me a plus or minus, if you go right to your calculator, 0.643. Okay, so this would be our answer for the cosine of 50. And just understand what's happening in the unit circle to confirm this answer here. If we were to draw a unit circle, okay, this is a 50-degree angle. All right, and right here we have our point xy. Okay, well, if we were to draw it over here in the second quadrant, okay, we have 50 right there. All right, if it's the same height like that, we have negative x comma y. Okay, so the angle's the same. Now the sine here is, the sine of 50 is 0.766. So the sine, recall, is the y value. All right, so the y value has to be a positive 0.766. I'm not going to draw it down below in the third and the fourth quadrant because the y values are negative there. Okay, so you can see there's going to be two possible answers here. So the cosine of 50, recall, that's the x value. So you're going to have both a positive and a negative answer. That's where you see the plus or minus over here. Okay. Okay, next we're looking to find the sine of 130 degrees. So 130 degrees, notice that if we were to draw this in standard form, I could actually use this diagram up above here. All right, 130 degrees would actually be this angle in the second quadrant, where you would have 50 left over, right? Because 130 plus 50 would give us 180. So the sine of 130 is going to be the same as the sine of 50. We know that from this diagram, we have A, S, T, C. So we know that sine is positive in the first two quadrants there. Okay, so the sine of 130 is going to be the same as the sine of 50, which is just 0.766. Okay, so the key idea here is to recognize that 130 and 50 add to 180. All right, if this were the sine of 131, we couldn't do it, okay, using that given information. All right, next one here. Suppose we wish to find the cosine of 130. So the diagram still looks the same. All right, but in that second quadrant, cosine is negative. And if cosine is negative, it means that the cosine of negative 130 is going to be the negation of the cosine of 50. Okay, so remember 50 plus 130 will give us 180. Okay, so we can just simply take the negative answer from what we have up above here. So negative 0.643 would be the cosine of 130. Again, we know it has to be negative because cosine is negative in that second quadrant. Okay. Next one here, we are going to find the sine of 230. So let's draw this. Okay, let's do this in standard form. A 230-degree angle would be down here in the third quadrant. And if you think about how far past 230 is from 180, well, there's 50 left over. Okay, should be no surprise that it matches what we have up above. Okay, if this were 231, it wouldn't work. So we're trying to figure out what the sine is. Well, recall ASTC, only tangent is positive down there, so we're expecting this to be negative. Well, it's the negation of the sine of 50. Okay, so imagine extending this through the origin. If that's 50, then this is going to be 50. Okay, 50 is the reference angle. Okay, you could also kind of tie in the unit circle. You could think about this as being the point x comma y, and think about this as being negative x, negative y. Okay, so the idea is that tangent would be positive there, so the sine one would have to be negative. Okay, so the negation of the sine of 50 would just be negative 0.766 from up above. And again, just in case you're not seeing it, remember the sine is the y value. So the y value, notice, is negated. Okay, so hopefully that makes sense as to why we are negating the sine of 50. Okay, last example here, the cosine of negative 50. So a negative angle means we're going clockwise rather than counterclockwise. So if you were to just sketch this real quick, negative 50 is down here. All right, I'm going to label it as a positive 50, but it just means we want clockwise 50 from our starting position here. Okay, now this would be the same as going all the way around a positive 310 degrees. Okay, just an FYI. All right, and notice how that's 50 away from 360, right? All right, so we're trying to figure out what this is equal to. And as we look at our ASTC, notice how cosine is positive down there. And because this 310 plus 50 gives us 360 all the way around, this is going to be the same as the cosine of 50. Okay, well, the cosine of 50, we said, is from up above. Well, there were two answers, but we want the positive one, so 0.643. Okay, and keep in mind too that if we were to draw positive 50, remember that if we were to tie this back to the unit circle, that's the point xy, and then if we draw it down below in the same position, it would be x comma negative y, and recall that cosine is the x value, so the x values are not changing. Okay, it's still the same sign. Goodbye.